Over to you. Hi everybody, I think we'll make a start there, please. Thanks. Hopefully everyone on Teams can hear us okay as well. If not, just let me know in the chat and I'll try and fix it. There's no camera working today for those on Teams though, because they've changed the setup in this room. It doesn't let you put Teams on the computer anymore, which is helpful. So, but we've got it running hopefully anyway. So, Belinda, if you want to do the introductions.
Hi everyone, thanks for coming today and for joining us online. Today it's my pleasure to introduce Ewan McHenry, who's joining us from the Woodland Trust. He's a conservation advisor in landscape ecology. Ewan is a quantitative ecologist working on the interface between applied ecology and management. He gained his PhD from Aberdeen on applied quantitative population ecology for adaptive management in conservation and invasive species management. He's also an honorary research fellow at the University of Manchester, and he joined the Woodland Trust in 2019 to advise on landscape scale conservation decisions with a focus on ecological functional connectivity, which I think is what he's going to talk about today. So over to you, Ewan.
Thanks very much, and thanks for having me. It's always nice as someone with a bit more of a practitioner hat on these days to come into an academic environment and have some good talks, and also maybe share a little bit about what it's like to work as a scientist in like a less of an academic setting where you're potentially more applied. Yeah, so I'm going to talk about it's kind of two talks that I've kind of segued together here, talking about habitat connectivity and also condition monitoring, with a mind towards building some kind of lovely adaptive management cycle where all our decisions are based on evidence and we account for things like uncertainty. And we'll never get there, but sure, it'll be fun trying. As I said, I'm a landscape and population ecologist, conservation advisor working at the Woodland Trust. I've been there for 5 years, something like that now. It's fun. Yeah, I thought I'd just kind of give a brief overview of the Woodland Trust, just in case people haven't heard of them before. We're a UK-focused environmental NGO focused on native woods and trees. We're a membership charity, so anyone can become a member of the Woodland Trust and get a nice magazine every quarter or so, and support us in our work. And that kind of membership charity thing has a whole kind of machine behind it that's part of the organization, you know, in that there's fundraising, membership support. There's a whole kind of area of my colleagues who work on that kind of stuff, and me and my colleagues I work closer with are kind of more based in the science kind of stuff. The trust has this vision which kind of drives all the work we do, which is a world where woods and trees thrive for people and nature, and that for people and nature bit is really important for what we do. And we do that through protect, restoring and creating native woods and trees. And that protect, restore, create mantra is something that you'll hear an awful lot if you have any involvement with the Woodland Trust. We have an estate of over 1,000 sites that we manage for nature and people. And these are all freely accessible to the public, which is something I'm quite proud of. I think it's really nice, the idea that anyone can go to any of our sites and not have to pay anything for it. We also have a lot of colleagues working in outreach with other landowners and working in big partnership projects that get work going and help manage and create woods and trees outside our own estate. So that's working with other charities, working with government, working with private landowners, a whole host of different partners that we work with. We also work with policy and advocacy to try and get some policy in place that will be good for woods and trees. And in my part of the organization, we do a little bit of research and try to provide evidence-based guidance and training so that we can get the best for woods and trees that we can going forward. So the part of the organization that I work in is called the Conservation Outcomes and Evidence Team. So as a scientist working in one of these conservation charities, we work on research. So we commission research, we fund research, and we also do synthesis and of that work. We have some people who work running different citizen science projects, the Ancient Tree Inventory, Nature's Calendar, which is a phenological citizen science piece of work that looks into the timing of different seasonal events, and Observatory, which is a tree health-based citizen science project. We also have this relatively new part of our team that is focused on monitoring, evaluation, and learning. It's really about formalizing adaptive management and baking that into the way the organization works in a way where evidence and evidence-based decision making really drives the work we do in a way that's formalized, so we know why we're making decisions, when we're making them, why we monitor things, and how that information from monitoring goes on to influence the decisions we make. In my little part of our team, these outcomes, we're more focused on translating evidence for practitioners through advice and guidance and training. And we have a neat little kind of partitioning of that off. We have one person, one of my colleagues, who works on woodland creation, advising on that. And then 3 different scales, one person who advises on individual trees, someone who advises on woodland sites, and me, I'm focused more on landscape scale advice and decision making. And that's me giving a version of this talk on a hill somewhere, which is kind of weird, but yeah. And the idea is that we're trying to build some kind of virtuous cycle where we do stuff for wildlife, monitor what happens, evaluate that, report and build our guidance and training on that, and we go round and round in this lovely circle where we keep doing things better and better and better in an evidence-based way. It's not always easy. The monitoring isn't perfect. We don't have a perfect view of what happens, what the response is to things we do. We actually aren't really focused that much on wildlife and the actions we take. Really, we're more focused on the woods and trees themselves, which is the habitat extent and condition. The influence isn't perfect, and we kind of assume this link where wildlife kind of does well because we manage habitat, hopefully well. And we don't understand that either. So yeah, there's all kinds of places where uncertainty creeps in, and that can be difficult for us as scientists to grasp and formalize, but to actually try and then influence the way that a big machine of an organization of hundreds of employees runs to account for this kind of imperfections in our understanding of things is a whole other challenge. Just a few kind of bits and pieces of what we do. We've worked in the state of the UK's Woods and Trees report, which and a bunch of other stuff, but it also kind of reporting on important facts and figures that relate to woods and trees. I guess in the UK, internationally, things aren't fantastic when it comes to woodland cover. When we compare it to our Western European neighbours, we're quite low, not as low as Malta, but I think they have a good excuse. We have, however, we've gone up in woodland cover since the war has doubled. Most of that has been conifer plantations, mainly in Scotland, and maybe not the best for wildlife. And at the same time as this increase in woodland cover, we're seeing a decrease in woodland wildlife. So birds, butterflies, all these indicators appear to be in relatively downwards trends. So this conundrum of why is woodland cover increasing and yet the wildlife that relies on it is decreasing is something that we try to grapple with. We think that's something to do with native woodlands with need to be in better condition. But yeah, that's kind of me, and my focus is landscape scale stuff. I am involved quite a lot in our priority treescapes, which are the priority landscapes where we try to focus more of our work and be more involved. They vary a lot in size. The Fochan Valley in Northern Ireland is pretty small. The entire west coast of Scotland is pretty big and complex. But yeah, I work a lot in them. They all have different priorities and themes and different goals that they're trying to obtain. But they all want to create some kind of transformational landscape scale change for woods and trees as habitat for wildlife. They often talk about ideas of bigger, better, more joined up woodland habitat, ecological resilience, and ecological connectivity. These ideas come from people working on the ground who don't necessarily have a very formalized understanding of what that might mean in the way that a scientist might understand it. But these ideas all come up and there is that commonality between them all. And I try to translate that into a way that can be reported on and monitored and, as I say, continue this virtuous cycle of adaptive management. Northern Forest, just picking out an example from that, it's this pretty huge area across the north of England. It's got 7% woodland cover, so it's pretty low compared to the UK average. It's got a very small amount of ancient woodland within that. But there's this huge partnership project that aspires to plant 50 million trees over the next 25 years. And that's kind of the headline goal for that. I'm not so interested in the number of trees that get put in the ground. That's not really very ecologically meaningful. I'd prefer to think about networks of habitat for wildlife populations where the kind of native threatened wildlife that we're interested in conserving can increase in their population growth rates and be resilient and viable for years to come. And as I say, we do this mainly through habitat management rather than intervening too much in individual species. Yeah, landscapes can be complicated things. I mean, if you look at this, which is actually quite a zoomed in picture of a landscape, and someone might come to me and ask, well, Ewan, how many trees do we need in this landscape? Where should they go? And those are the kind of questions that come to me. Normally, actually, at a much bigger scale than this. Normally, at like a scale of like tens or hundreds of kilometers. And that's a complicated question because there's so much complexity going on here. Should we focus on one woodland and try and make it better conditions? Should we create new woodlands? Should we make some woodlands bigger? Should we try to link together woodlands that exist in the landscape? And all this mess of what's already there, different types of land use interacting in complicated ways, it's complicated. So I first try to simplify things down an awful lot. So I tend to talk about the patch as a discrete unit where all the good stuff lives. That's the stuff that's capable of supporting the kind of populations of species that we're interested in. And they're connected together by ecological processes like dispersal. And this matrix that dominates the rest of the landscape is unable to support reproduction and long-term persistence of populations. And that's nice. That simplifies things way down. And that allows me to start talking about how can we measure this resilience thing at big scales. So yeah, and thinking about meta-populations and the connectivity between them, these individual patches, when you talk to a site manager, if some species of butterfly that they're interested in goes extinct at their site, they might be quite worried. But at the landscape scale, it may still be relatively stable. There can be, as you know, frequent extinctions and colonizations of individual patches, but we can maintain stability at a landscape scale. And in isolation, without dispersal and connectivity between these patches, everything would eventually go extinct. So there's the connectivity between the patches that promotes recolonization of extinct patches, rescuing of declining populations and patches that might exist in the landscape, the shifting of species ranges in response to climate change and genetic mixing to prevent the negative impacts of inbreeding. And like going back to my former days when I was interested in voles a lot, we can see in different kind of patches of voles, there can be loads of extinctions and colonizations of individual patches. And yet the number of occupied patches in the landscape can retain quite a large amount of stability. And maybe there's something that we can learn and bring from these like weird kind of vole systems and bring into woodland systems as well. So whenever I joined the Woodland Trust, they kind of pointed me in the direction of this connectivity thing, which I had some experience with. And thinking about how to start measuring it, there was an awful lot of talk about bats as indicators of landscape scale connectivity, and I wasn't necessarily convinced. So I started thinking about what can we do to build landscape scale resilience. This very impactful report from some years ago, Making Space for Nature, talks about bigger, better, more joined. The Lawton principles are quite often quoted. Creating landscape corridors, buffers around existing woodland, things like that. Bigger and better habitat is quite simply so we can have more resources for populations, more reproduction, less death, and more joined together means greater dispersal success between those populations. That means more recolonizations and more rescue and more genetic mixing of populations. And I want to build some kind of a tool to measure progress towards this thing, this kind of like bigger, better, more joined upness at landscape scale, in order to report and measure the progress that we make and relate that to the things that we're doing in order to target the work that we do and prioritize different actions, different things to do. Are we restoring in some areas? Are we creating woodland in others? And where we do them as well. We don't have a lot of money to spend on lots and lots of monitoring across the whole country. So it needs to be something that was relatively simple, that we could collect data on relatively easily. So using existing data sets, and be relatively simple so I can communicate it to my colleagues and yet ecologically realistic. So I kind of set about doing that based on, I must say, it's down the shoulders of giants who worked in this kind of area. So not inventing anything new, but creating this model of functional connectivity at landscape scale. So habitat patches in the landscape where species can reproduce, say butterflies, and the bigger and better patches have more butterflies in them, and they reproduce more, so they have more offspring. And you might imagine this relationship where the bigger and better patches have more population viability. You might imagine that's a relatively linear relationship, and maybe there's a minimum point at which patches are so small that they can't sustain viable populations. So maybe that intercept isn't zero there. And this is nice because now I can get rid of the butterflies and just talk about patch size and quality, which is simpler. And these more joined patches, which are going to have better dispersal between them, how can I quantify that? Well, first of all, I need to think about what this dispersal thing really is. Dispersal isn't just a process of species moving around the landscape. It's whenever an individual leaves where it was born, travels through this matrix, a very dangerous place, arrives at a new patch, and then contributes to that new patch's future population. So until it's contributed to the future population on another patch, it hasn't really effectively dispersed. So bats flying along hedgerows back and forth from where they sleep to where they eat isn't really a good measure of this kind of connectivity thing at landscape scales. Yeah, and we might imagine that dispersal success follows some kind of a negative exponential relationship with distance. Every time you go 500 meters, you flip a coin. If it lands on tails, you get hit by a car. And you go another 500 meters, and this process kind of repeats itself. And you get a nice little shape here. And we can estimate these distances. We can take the median effective dispersal distance, so if whatever kind of species we might be interested in, or some kind of generic focal species that represents the kind of species that we're interested in, and we can parameterize this as an actual model, which is fun. We might also think that, well, not all the matrix is created equally in terms of facilitating dispersal. We might see corridors in the landscape that facilitate dispersal or barriers that block it. So these are all things we want to think about. So there we're not just thinking about distance, we're thinking about ecological distance, or the cost of moving between different patches in the landscape. And it's got some nice maths to go behind it, which, you know, it's always fun. So we bring together these bigger, better, more joined ideas into this functional connectivity metric, which is the way we can measure these things. And, you know, this work's been done before. I'm not creating anything new. It's all relatively nice maths. It talks about the links between different patches. And that's cool. And whenever I talk to this, and normally I'm talking to less scientifically minded people, what I really try to emphasize here, by measuring these things in the same units, this complexity, we can use the same units to talk about an individual patch and its connectivity to itself, its isolated functioning. We can talk about the input or export from an individual patch. What's this patch's value in the whole landscape? Or we can talk about all the links between all the patches that exist in a landscape. And we're using the same units for all these different things that we're talking about. And that's cool, because we're talking about in this really weird scale that no one really understands. We can talk about all this complexity at different levels. And that allows, we can do this little trick then, where we take our real world landscape and all the complexity, we get the number for it, and we can ask ourselves, well, what if there was one patch that had the same functional connectivity, what size would that patch be? And then suddenly you can talk about this complex thing that brings together the quality, size, and connectedness of habitat, and you can talk about it in terms of hectares, which landscape practitioners can understand. Site managers know what it means to restore 1 hectare of woodland. And you can say things like, what if we doubled the landscape connectivity, the functional connectivity of this landscape over the next 30 years? That's like a good goal that we could set ourselves and measure our progress against. So equivalent connected area. What's it look like in real life? This is a 5 kilometer landscape across somewhere in the southeast of England. The red areas here from the land cover map, this is from CEH's land cover map, which is a cool little tool. The red areas are broadleaf woodland, so this is habitat that we're interested in. And there's other types of landscape cover out there as well that might be better or worse for our woodland wildlife. So we can quantify the area quite easily. The size, it's right there. The quality bit is difficult. So really what I want to do here is I want to take these different areas and weight them by their quality. But I can't pay for someone to go out and monitor all these different woods. So what I'm going to do is I'm going to take the ancient woodland inventory, and we kind of assume that ancient woodland is of a higher quality than non-ancient woodland. It's been there for longer, it has more ecological continuity. And we can say that area is of higher quality than anywhere that isn't ancient, maybe. We'd also maybe talk about the negative impacts of neighboring land cover types. So things like arable land might have a negative impact on woodland that cuts in quite far. The pesticides that are being used there, the different environment might have a negative impact that cuts in on the environmental quality for the kind of species that we're interested in, these vulnerable species off woodland interior. And we've got numbers for this. We've got, from the literature, we've got ideas of some estimates of how far these different neighbouring land cover types might cut in to the quality of woodland. I'm going to bring those two things together and throw some numbers at it that I obtained through a little bit of expert opinion and elicitation to get an idea of the quality, the relative quality of these different parts of our woodland. So there you've got different components of different amounts of quality. We can bring them all together to get an average quality for each of these individual patches. So now I've got the area and quality of our different habitat patches in the landscape. So what I'm going to do is I'm going to weight the area by the quality by multiplying and applying them both together. And then I'm going to make them into circles so you can see the different sizes. So that's what I've done there. So now we have area weighted quality of all our different patches in this real world landscape. The bigger circles are bigger and better. I'm now thinking about the more joined upness of them. Wait, what's going on? Hey, yeah, there we go. Different costs of moving through different parts of the landscape. Again, we've got numbers from the literature that we can use for this. Using at least cost path models, we can estimate the ecological cost of getting from, say, one focal site to any of the other patches that exist in the landscape or beyond. And we can convert that into a probability of successful dispersal by using the same function that I showed you before. That's cool. So we've got here kind of a focal patch and the probability of successful connectivity of successful dispersal between it and all the different patches in the landscape. And we can bring back in the quality weighted area, the bigger and the betterness and the more joined upness of it, and look at all the complexity of all the different patches that exist in the landscape. The thicker lines here are more joined together, and the bigger circles are bigger and better. And we can also look at the impact of habitat that might exist outside the landscape. So it's kind of import that is getting into the landscape. And then we can, this is all complicated, you know, to kind of like try and explain this to someone who's trying to make decisions between different hexagons that might exist in the landscape. Throw our little mouths out and we get there. That's it. That's the equivalent connected area of this individual landscape scale square. And we can plot that across entire landscapes now. So now we start to see this really, really big landscape, and we can pick out the hotspots for ecological connectivity that exist around it and use that to target our work to expand, enhance, and link together the hotspots for ecological connectivity that exist over really big landscapes. And that's cool. Because this data set, this land cover map exists all the way back to the 90s, we can make comparisons and look for a little bit of spot the difference. We can say, okay, here, for instance, there was a big woodland creation project around the River Mersey, and it comes out really, really clearly. In fact, we can make it a bit easier and look for change within individual hexagons. So the blue ones have gotten worse and the yellow ones have gotten better. So what's the stories behind this? And that's whenever I go and talk to the actual people on the ground who know this kind of stuff. What projects have been going on? What are the threats in these different areas? How can we combat them? For instance, here, this area here around the Peak District National Park, a real hotspot for woodland connectivity, seems to be doing really poorly over the last 30 years. What's the problem there? I think it's sheep overgrazing most likely. But this is evidence that we can then bring to the people who have the power to make these decisions. Say, what's going on here? This needs to be changed. One good thing is, over this entire landscape, we've seen a 13% increase in the equivalent connected area of habitat, which is cool, because it means that even without this focused effort, things seem to be on an upwards trajectory. What it means is, though, if we want to do better, now that we're focusing on this landscape, we need to be doing even better than 13% over 30 years. This isn't a flat baseline. The baseline is already increasing. If we're going to make good use of an investment of effort, we want to do even better. And I've done that for all our different priority landscapes. And now, you can bring this to the folk who are focused on these landscapes and chat about where they might want to prioritize their time and resources across the landscape, as I say, in order to expand, enhance, and link together these hotspots that already exist. And find out where the threats are as well. And sometimes there's really clear patterns. Like I say, they're around the Peak District. Here on the western side of our Wield and Downs treescape, things seem to be getting a lot worse. What are those problems there? So here's just a little example of how we might use this in actuality. This is a map of the amount of conifer plantations on ancient woodland sites within individual land holdings. So if someone working in outreach who works with other landowners wants to pick one landowner to go and talk to and convince to get on an ancient woodland restoration pathway, which one do they pick? Well, it's going to be the one where they can restore the most ancient woodland for that conversation. So they would pick one of the more red ones, right? But then we can overlay this connectivity over the top of that and talk about, okay, well, maybe this landowner is important and there is a lot of ancient woodland that's under threat there. But if we took that same effort and focused it more here, we'd be creating a restored habitat that's more able to be colonized by the kind of species that we're interested in conserving. That's cool. So yeah, I don't know how I am for time. I also want to talk about connectivity, about condition. I think I've got time to get onto that. So yeah, as I said before, this approach to estimating the quality of individual patches probably isn't fantastic. It's really a pragmatic decision that I made in order to nod towards the idea that not all habitat is created equally. It's far from perfect. Expert opinion thrown at it to get these really, really rough ideas of how one bit of woodland might be better than another. But I need some kind of data that will allow me to inform things over a big landscape scale. I need to be able to estimate the condition of all these woodland patches in a way that we just can't afford to do individually. So it dovetails really quite nicely with some other work that we've been working on woodland condition and monitoring that, and ultimately, hopefully in a way that will allow us to even estimate the condition of woodland, maybe based on remote sensing data that is beyond the areas that we have an actual involvement in. We don't really have a great understanding prior to this about what condition really is. And that's the first thing we need to nail down before we start answering questions, the kind of questions that an environmental NGO like us should be able to answer, like what is good condition, which woodlands are in good condition, how many of our woodlands are in good condition, how many of our woods are improving in the condition, are we even doing a good job, and what decisions make better condition. Is one decision better than another? How can we improve condition as fast as possible? So I kind of, like, through consultation with quite a few folk that I work with, we came to this definition of ecological condition for a woodland. We came to the potential for a woodland site in its current structural state to sustain biodiverse, dynamic, and well-functioning species communities. The word potential is in there because we're not interested in how long it takes for species to arrive at the site whenever we're creating good quality habitat. We're kind of assuming that if we build it, they will come eventually. But at the same time, in its current state is also really important because we don't want to, the condition of a site is a thing that does exist at a certain time. If there's some kind of invasive removal program going on that might reduce the amount of invasive rhododendron on a site in the future, we don't want to account for that. We want to be able to measure the progress of those kind of management actions. So we want to do this. This is to inform site managers, the people who are responsible for individual woodlands. We want this to be a fundamental form of condition monitoring that we apply through all the sites that we're involved in. It's for woodland, but really we think the approach that we're using can probably be generalized across quite a few different habitat types, albeit in slightly different ways. And we want to make this comparable to the way other people are reporting on woodland conditions. So Forest Research and the National Forest Inventory are reporting on woodland condition across GB. Biodiversity net gain is really becoming quite important, and this means an actual dollar amount is going to be put on the quality of woodland. So suddenly this starts to become a bit more important, and there's real sensitivity in what might happen whenever you start actually linking currency to this idea of condition. So we want to do this in a rigorous way, so it's being done as well as possible through our advocacy work and working with others as well. We want to do something that's consistent across the UK and repeatable as well, so that we get good quality data in the future that we can monitor change in. Yeah, so the basic idea is we go out to the woods, or we use remote sensing data and we measure some things. And we measure things in like actual real world units, like number of different tree species or the diversity of age classes. Things can actually be linked to a unit of measurement. And then we convert that into some kind of a value using value functions and weighting, some kind of function, some kind of mathematical function that takes the measurement and converts that into a value that then contributes towards ecological condition. Those weightings are just like the idea that different indicators for a woodland condition might have different amounts of importance. And the value function is that shape. What does good look like for an individual indicator? How many tree species you might have in a site. And you get a whole bunch of different scores then, different values for your different indicators, and you compare them to each other for an individual site. And you can also aggregate them together to get a score for the site. And maybe you convert that to like a 1 to 100 scale. And maybe you apply some kind of relatively arbitrary thresholds that allow you to say something like, this site is in intermediate condition, or this site is in good condition, or 50% of our sites are in bad condition, or whatever. And yeah, so we've got all these kind of different structural indicators that we're using to do this with. There's 15 of them, and they're very comparable to what other people are doing. For instance, what biodiversity net gain is using. They get very, very similar actual indicators. They classify each of their indicators as good, moderate, or poor, and they value them as 1, 2, or 3, and then add all the numbers together. And it's basically the same idea. We're just allowing a little bit more nuance. So rather than being this idea of like categorical condition, their value functions are essentially categorical and essentially have the same weighting across all their individual indicators. We're just allowing a little bit more flexibility with that. So here they have low, medium, or high for each of the individual indicators and add them all together. But why not allow it to be continuous? I mean, why not? The difference between 29 and 31 shouldn't be this big jump. In fact, you could even be more complex than that. You could allow condition to increase very rapidly over a certain scale of measurements, and maybe it plateaus, and there's a certain point where you don't really care about how much more once you've got 20 different native tree species, you don't care about the 21st coming along. It's not going to affect really the ecological condition of the site. Or you get some kind of optimum where you get too much of a good thing as well. And by just kind of rethinking the way this problem is phrased, we can bake in much more flexibility to how we measure it. Or it can even be contextually specific. You could have a certain type of woodland where something like native tree cover is a good thing up to a point, or you could have something like wood pasture characterized by relatively low tree cover, and the biodiversity depends on that, and you could have the value kind of slow down if that's the context you're working in. So just for example, for how this might work, and two little toy examples, we've got two little woodlands here, and here I'm only going to talk about two indicators. So we've got the percentage of native tree canopy cover, the number of age classes present. So two woodlands, woodland 1, 100% native canopy, 2 age classes. Woodland 2, only 50% native canopy cover, but 3 age classes present. So how might that look? Well, if we weight tree canopy nativeness really high, then it's going to look differently. But excuse me. So the value function doesn't really differentiate between very much. If you reach 50% native tree canopy cover and you don't get any better value, you end up with scores that are relatively comparable. Here in this instance, the number of age classes has won out, even though it's weighted not particularly highly, because that's where the real difference is. If you change that value function so that the proportion of tree canopy nativeness is really important, and that's where the big change is, you get a really big difference, and woodland number 1 comes out as much more important, much higher ecological condition. And you can do it again, changing the weights. The point I want to make here is that the reliability of these value functions and weightings is crucial. That is what condition is. That the way these things are defined mathematically is the definition of condition whenever you do this kind of monitoring. So in an ideal world, we'll go out and measure really important things and look at biodiversity responses and account for time lags but we don't have time. Also, whatever result you got from that might be incredibly tax specific. So if you're looking at dragonfly biodiversity, you get a very different answer than if you're looking at avian biodiversity, for instance. So we decided for this to take an expert opinion based approach, which isn't really something I had a lot of experience with previously, but I'm enjoying it. So we could go and ask an expert, how does the proportion of native canopy affect condition? And they might tell you, well, the function looks something like this. Or you could go ask another expert and they could say something different. And you probably get a different answer for each of the experts that you asked. But then you can do something nice where you show everyone their answers and say, well, this is what all your colleagues think, all these people that you respect and work with. Do you want to change your mind? And they say, oh, well, I was way off. Yeah, I'll change my mind. Maybe this one here could come down a little bit. Maybe that could go up. Oh, I put in way too many points. It's not that complicated. Okay, cool. So now we start to approach some kind of consensus. This is called a Delphi technique, where you go through different rounds iteratively, and people get to change their mind based on the answers that other experts have given. And it's fun. And as well as going through this process, we've got 29 of my colleagues working in the kind of operational end of the Woodland Trust. And they've got a wealth of knowledge built over entire careers, looking at these things, seeing the responses of wildlife. And we were able to capture that through this process. And that's just, yeah, really cool. So it kind of worked like we got them into workshops and they helped us figure out how these things we measured. And I gave them some really boring Excel spreadsheets that they could fill out and doodly-doo, pop their numbers into and build their value functions and weights, which is fun. And then we did this. I don't know if any of you have used Quarto and interactive figures and stuff like that. I think particularly for something like this, where you're trying to engage people who aren't necessarily data people in data and trends and stuff like that, it's like really invaluable. And they can compare and they can see who did what, and okay, I respect their opinion more than this person, so I'll change my mind a little bit. And as well as that, we get, there's a lot of bonus stuff we get from this collegial approach that we took. First of all, this isn't me coming from the scientist team and saying, you've got to do this way. This is how condition monitoring is going to look. This is their metric. I've just provided a mathematical framework for it to work. Really good buy-in from folk, and that just is so valuable. They've also given us lots of feedback on how we propose measuring things, and we've changed a lot of the way we measure these different indicators. Also, a lot of knowledge exchange, both between us and them and each other. And you know, at the same time, I think maybe kind of challenge them and how they think about condition and how they weight different aspects, and maybe they even learned a little bit about miles and stuff along the way, which is fun. So yeah, so how these things actually, a lot of them didn't actually change that much. This is just some bootstrap, like the uncertainties through some bootstrapping, just to kind of show the variation there. Some of them didn't, the actual fundamental, like the actual functions didn't necessarily change very much, but maybe became more certain, possibly just kind of taking the average of an average and just kind of coming in around whatever the mean was. But yeah, we can be more certain in this if our colleagues are iteratively agreeing that, yeah, this looks about right. For some of them, they changed a little bit more, though. And for other ones, they changed quite a bit. So this idea of anthropogenic damage, there was a really wide range here, and actually it shifted quite a bit from over here to anthropogenic damage maybe not being as important at lower amounts. And yeah, we did this for all 14 or 15 of our different indicators. And now we're at a stage where we think we can be relatively confident about what these different functional shapes look like. The weightings, on the other hand, everyone's got a really different idea of what's important and where. And no amount of statistics you can throw at this, looking at like principal component analysis of, okay, I know what's going on. I looked at this data. I know what's going on here. All the Scottish people, all the Scottish site managers think that herbivore damage is really important, and they think that the veteran trees are much less important. So I'll do a principal component analysis and look for these. No, nothing like that, I'm afraid. So this is a challenge for us to try and still make something out of. And I think this will iron out as we begin gathering data and relating it to biodiversity trends going forwards. Just to give you an answer for our two different woodlands, the one with more non-native canopy comes out as slightly higher score, only using those two indicators. But that's interesting for an organization that's so focused on native tree species and native woodlands, that actually native canopy cover didn't come out as one of the things that drove this condition score completely. Yeah, cool. That's me. Yeah, I'm happy to take any questions. The Delphi process, very fun little backstory going there all the way back to ancient Greece. All the code for what I've showed you is on my GitHub. I'm really happy to chat to people about that side of stuff, what it's like to be someone working in kind of quantitative ways in an organization that's much more about actually doing stuff. And yeah, cool. Thanks very much.
Thank you. Does anyone have any questions in the room or on Teams? If you're on Teams, you can put it on the chat or raise your hand and I'll come to you in a second. But I'll give privilege for those who are in the room. Right. Yeah, Doug.
I probably will be a discussion more than a question. I'm from Portland Forests. Some of the stuff you've been talking about is really interesting for us because we're trying to enhance connectivity through the Forth Valley area and forest. So I suppose the principal thing is how easy is it to use your modelling, particularly when you were talking about the functional connectivity in host sites. Is it easy to remodel that in different geographic areas? Obviously, you've done it within your 10 kind of forest landscapes, but could you easily apply that to other landscapes as well?
Yeah, I think that's probably where my work's actually added the most value to this, because these aren't crazy new ideas I've come up with here. This is all just kind of me taking stuff from the literature and then operationalizing it. So yeah, we've got to a stage now where I can take a shapefile of any landscape and create one of these maps for it at different spatial scales, which is good. We want to be able, I was chatting with a colleague there last week where there was a potential site for acquisition came up, and we had a look at, okay, where is that site in this landscape? And it's like, oh, it's this huge opportunity. And I'm like, actually, that's not really in one of the areas that I would probably say this is important at landscape scale. So we're able to go to the people who are making these decisions about acquiring new sites and say, well, actually, you may have all these other benefits go along with this, but don't talk about connectivity and stuff whenever you're trying to value this action that you're doing. So in answer to your question, yes, we can print out these maps for whatever landscape you're interested in. What I want to get to next is I want to say, if you have a polygon of whatever kind of habitat creation or restoration work that you're going to do, how does that actually, can we quantify how much that impacts the wider landscape and create a tool for that will allow you to compare, say, an action in one site compared to another. If you did 10 hectares here versus 10 hectares there, what impact would that have on the wider landscape and its functional connectivity? And that's all assuming that your kind of objective goal is to maximize this functional connectivity thing across the landscape, which you might not want to do for whatever reason. You might be wanting more focused on extent, or in different lands, there's different costs that come with different actions in different areas as well. Yeah.
Any other question? Alan, and Dan after.
Thank you. I'm thinking about sort of random and extreme events and how the models affect, particularly as climate's becoming more extreme, droughts and floods, and is it even possible to model this for something you've not found?
So I guess with climate, we're probably so we talk a lot about climate impacts and building woodlands that are resilient to them, and wooded landscapes that are resilient to climate change. And it's, some folk talk about moving tree species from an area of province that's further south. We don't really talk about that so much. Our line is that our native woods and trees and wildlife have enough diversity in them to adapt. Let's see how it goes. But I think where we end up, how we reconcile that is, we say, like, if areas have good extent and condition and to some degree joined upness of woodlands and habitat generally, they'll be more resilient to landscape. If we can see in it like more diversity of greater structural elements within woodland, will in-bake redundancy and more resilience that way. Yeah, extreme events modeling them, no. So I think, yeah, we make a leap of faith at some point. Yeah, with regards to that. I do think there's something in, if you've got landscapes of habitat patches that are well connected and are of good size and quality, where populations are not so threatened that there will be a certain amount of resilience baked into that.
Dan?
Yeah, thanks. That's really, really interesting. Well, the sort of maps of functional connectivity producing the change over time for identity. Is there any way you can actually validate the effects it drives on biodiversity? Maybe looking at patterns of colonization or species movements or spread or something?
Yeah, I think it's with time lags, extinction debts, colonization, credit. That kind of stuff makes it really, really difficult. Yeah, I'd love to work on that kind of stuff. There's no way the Woodland Trust is going to pay me to answer those questions. but yeah, those are really important questions. Like, how long will these things? How long are extinction debts going to last? In relation to this kind of landscape scale change as well. So it's so complicated, and yeah, I think that's a real area of research where we need to have more done for sure. Yeah, so no, I don't know.
There's a couple of questions on Teams. Well, one was just about a paper from Kevin Watts. You know who Kevin Watts is? Okay. Okay.
Yeah, I know.
I can forward this on to you,
Cool.
that paper, if you don't know it and you want it.
Thanks, Kevin.
There's a question from Rachel. I know that Edinburgh Zoo is working to conserve the dark bordered beauty moth that relies on aspen. Is there work being done to conserve aspen by the Woodland Trust?
Yeah, there's some Trees for Life are doing a lot of stuff on aspen. Now you're stretching me here, but I went and chatted to someone at Trees for Life up in Dundragon last year, and they were doing some nursery growing of aspen. So something about aspen being like sexually reproductive, but I forget. There's some kind of issue of connectivity at like relatively small scale for aspen to reproduce and to sexually reproduce. I think it's interesting when you talk about connectivity, like these different scales of connectivity and connectivity for different things can be quite interesting ideas. So here I'm thinking about, whenever I'm talking about connectivity in this context, I'm thinking about a generic focal species that can disperse about 5 to 6 kilometers and like does so in a way that relates to habitat type. And that's dispersal. That's kind of like a once in a lifetime event that allows different populations to be joined together. But you could equally think about it as the dispersal of gametes and reproduction across a landscape. And in those instances, your dispersal part of that model can be very different. Or, and I've had colleagues come and chat to me about this, we could think about species that are really, really specific in their habitat requirements and really dispersal limited. So you could be talking about the kind of invertebrates and fungi that live within the decaying heartwood of ancient and veteran trees, and how they're connected across individual sites. So I think you could take this kind of mathematical framework and adapt it slightly, change the dispersal model a bit, and try and answer those questions. But that's definitely not the specific question that I'm trying to answer here.
And the final question from Teams from Kevin Watts again. Do you need to triage your actions at the Woodland Trust? With some areas or landscapes already connected enough, and some would require too much action to reconnect, and a sweet spot of landscapes in between that could be improved with minimal action? Yeah, good question, Kevin. Thank you very much. So the way that, and obviously at the same time, there's a lot of stuff in the literature about the biodiversity fragmentation debate that rages on about whether or not fragmentation is good or bad for biodiversity. Fragmentation per se, once you've accounted for habitat quality and area. The way I'm reconciling this right now is that I'm using this connectivity metric to present our priority landscapes with two different objectives that I think are complementary to each other. So I'm saying that we want to increase landscape scale equivalent to functional connectivity of the whole landscape. I'm also recommending that we try to increase a percentile. So take the 30th percentile of the different hexagons in this landscape and increase that so that we are also spreading that effort out towards other parts of the landscape as well. Why 30? Because everyone's talking about 30 by 30, and 30 seems like a good number. But I think that approach does allow
pragmatic decision making isn't always focusing on expanding the very biggest patch that exists in the landscape, because that isn't what we want. We don't want all habitat restoration work to be focused in the southeast of England. Okay.
Another couple of minutes if we don't want to finish on that. Please.
Yeah, I was really interested in the last bit of talk when you were talking about the using the expert opinion for ecological condition. What are your plans with this next?
Yeah.
Would someone eventually be able to take that and apply it to?
Yeah. Yeah, I think so. I think. What do I think about this? I think there's always going to be different levels of intensity with which these kind of structural metrics get measured. But yeah, we want to make our method available to whoever wants to use it. And we might consider making like the next level down of our method that could be used by farmers, say. It doesn't require so much ecological expertise. And then maybe build some kind of a model that accounts for the differences in uncertainty around your final score there. That would be really cool. But yeah, absolutely. We're in the middle of designing an app to do the woodland conditional assessment that will like allow, and this is kind of like what I talked about at the start about this whole idea of working for a big organization that has all these different parts to the big machine and running. It's not as easy as just clicking your fingers and saying, okay, let's do it this way now, because people have their own ways of doing things. There's whatever you had working before, you've kind of got to change, manage that change, and different people have different reactions to it, and sometimes very emotional reactions to what and site managers maybe think, oh, you're going to use this to assess me and my ability as a
challenges within that. That was actually one of the challenges that it's not just about being perfect monitoring, it's about changing traditional approaches to things, and because you've got some new evidence which suggests actually maybe there's do you see that as being a key challenge for effective monitoring? It's sounding nice on paper.
So I came out of my PhD like a real, not even an advocate, an evangelist for like formalized adaptive management with Bayesian models everywhere, and like uncertainty being propagated all the way through all actions and the different costs of like some beautiful technocratic solution to this. And you read the papers, and the kind of this like institutional inflexibility is the phrase that kind of gets used to deal with that problem, as though it's just this really simple thing. Like if only the institutions were more flexible. But it's like, so yeah, that is the hurdle right now that I think adaptive management faces in becoming actually operationalized. So we're going through this process of starting to formalize things using the conservation standards approach, which is basically just a kind of a branding for some kind of adaptive management. But I think what it does successfully is it attempts to translate, and really it's about branding as well, but it translates the kind of thinking behind adaptive management into a way that like a corporate entity can understand. And it talks about things like project management and like theories of change. It talks in their language a bit more. I don't know if that's the solution to it, but I think that's the problem. The problem is translating this thing that in ivory towers we might understand very well to getting quite a complicated beast of an organization to actually enact. I think you can get individuals on like a small scale to work with these things relatively well, but then that reach is limited. That's where, and I'm not so interested in that side of things, if I'm completely honest. Kind of like corporate branding and like communicating to business leaders and stuff like that. But maybe that's where actually we need to bring in expertise outside our discipline, and building in adaptiveness to how we go about doing that. You can get quite meta about these things very quickly, I think. But there's definitely something there. I think just kind of waving our hands in this idea of institutional inflexibility isn't particularly useful.
Right, one question from Nigel just before we finish. It's quick and with a quick answer.
Really like to talk about collecting wisdom and so on. depends on who you ask and their motivations and what stakeholders represent there, but also that you're very easy for it to become kind of fixed aspect of got involved with new knowledge essentially.
Yeah, absolutely. So I view this work that we've done to parameterize this model as a prior to something that then will get iteratively updated through some. I think we need to be confronting this with, and from the very get-go, we need to think, okay, in 6 years' time, we're going to have rolled this out on however many percentage of our sites twice, and we're going to have data back, and we're going to be able to actually confront what we've done, and we're going to know which management interventions we've done. We're going to have some idea of biodiversity response, and like this is just a prior to get us going. This is like coming from a place where these different structural elements are thrown into 3 boxes and given a score 1, 2, or 3. This is just like building a framework that allows that to be a bit more flexible, and then a framework that can be adapted going forward. Yes, I think that's the most important thing. Like maintaining adaptivity into how that can be changed going forwards. Particularly the weightings. I think that's going to be worse. Like, yeah.
This was at 2 o'clock, so I think we'll wrap up there. So it leaves me to thank Ewan for his talk, and are you sticking around for a little?
Yeah.
Ewan,
Yeah,
if anyone wants to have a chat. Thank you very much. Thank you. That's appreciated.